Hey everybody, this is Larry. This is me doing the weekly premium Abo challenge problem. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem and today's whatever. If you watched today's daily problem, you'll know that I'm very hot right now, so I'm so tired. So, and didn't even sleep that well. Watch that video if you wanted some context. It's not that important, but it's just an excuse for if I'm messing up. Excuse me. But okay, this is a problem I haven't done before. The ratio is not super good, we'll see. 1548, the most similar path in a graph. We have n cities and m bidirectional roads, where road sub I is equal to A sub I, B sub I connects city A sub I with B city B sub I. Each city has a name consisting of exactly 3 uppercase English letters given in a string of names. Starting at any city X, you can reach any city Y where X is not equal to Y, i.e., the cities and the roads form an undirected connected graph. Okay, yeah, it's connected. Okay. You'll be given a string array target path. You should find a path in the graph of the same length of the minimum edit distance to target path. You need to return the order of the nodes of the path of the minimum edit distance. The path should be of the same length of target path and should be routed. There should be a direct road between. Okay, if there are multiple answers, return any one of them. I know what edit distance is. I think maybe. All right. Okay, so n is equal to 5, you have 5 roads, you have names to the roads, target path is equal to Atlanta to DXB to HND to Lux. Has to be of the same length, right? Okay. I was double checking this edit distance thing because, you know, very often edit distance you can add and subtract items. Or maybe I made that up, or maybe I'm confusing different metrics or whatever. So that's also possible. But either way, so that's what I was double checking for. Okay. What are we returning? The order of the nodes and the path of the minimum. Okay. So you want to go Atlanta to DXB to HND to Lux to LAX. Lux? My Alexa is thinking I'm talking to her. But man, this is a messy problem. If each node can be visited only once in the path, what would you? I don't know. I don't even know what I'm doing yet. So okay, it is a hard problem. Oh, n is equal to 100. So that means one notable thing that means is that you can do an n cube thing, and what I mean by that is that you can store every all pairs shortest path type thing, right? So that's something that jumps out at me for now. Everything else is pretty straightforward. I imagine this is just dynamic programming, to be honest, though, and just like a. Can you prove force? So the path, the length of the path is 100, and you can be at one of the 100 nodes. So that means that I click on this by accident. That means that the states is going to be only 100 square, which is 10,000, right? And then you can brute force a 100 thing. I think that should be good enough. So that's just dynamic programming, then, despite all the kind of funky stuff. The tricky part is that you do need path. You do need path reconstruction. So you cannot naively. Or I mean, you can. And I will, but you have to do a little bit more than that, I guess is my point. Alright, let's do it. I don't think this is that bad. Sorry. I'm stalling because I'm chewing. Not gonna lie. First, we want to target path in nodes. So let's just say lookup is equal to whatever for index name in enumerate names. Lookup of name is equal to index. Right. And then now path is equal to for I don't know, name in target path. Path dot append lookup of name, right? Straightforward stuff. Basically, I just wanted, you know, so that we could do. I mean, it's only 3 letters. It's probably not big of a deal, but it's just slightly better. Maybe, right? Okay, and then now dynamic programming, right? All right, let's do it top down. We'll see what happens. I don't know. It becomes like ham cycle or ham path, which is actually like, I don't know. Would be pretty hard. Anyway. Oh yeah, adjacency list as you go. Just setting up the adjacency list, of course. And then now what do we do? So then now we have to set up the dynamic programming. Yeah, so then let's just say similar, whatever, right? So then now you have the current index. This is the index that we're matching on the path, and then the current node that we're on, and that's pretty much it, right? So then the idea here, we'll do the path reconstruction afterwards. It's really not a big deal. If index is equal to n, where n is equal to length of the path. Oh no, that's a little bit confusing. P the length of the path then, because we have n here. Let's make this big N also. So if index is equal to P, then what do? We don't even need n in this, I don't think, per se. But in either case, if index is equal to P, then we return 0, right? Because basically we just try to calculate the edit distance. And the idea here is, given that we're on the current thing, there are 2 ways you can do it, which is why I'm thinking which one is a little bit cleaner. One is calculating doing the difference of the edit distance here, or doing it forward. It's both really the same. But yeah, for v in adjacent list of the current, right? If v is not equal to what's it, path sub index? So path sub index or path sub index plus 1 maybe? Should be a path sub index plus 1. That means that if this is this, then we should return 0, not at P. That's why I was a little bit confused. Because now you're at the last node, you're already done, we could return 0. Or maybe I just do it here. Fine. Return, or if current is equal to path sub index, then return 0. Otherwise, return 1. And then here we can just do similar of index plus 1 v, and then we have like a best, right? This is the best thing, so then the send node is going to be some big number, and then now we have best is equal to min of best similar plus, I don't know, delta or something, right? Where delta is basically this thing, and we can maybe rewrite it to here. Something like this, right? And then now, yeah, and then we return best. Let's return nothing for now, and then we could print out similar 0. Well, 0 is right, but the current node might not be right. You can start path of 0, but that's not technically right either. You don't have to start. I think the first item doesn't have to be the same. So basically what you would actually do is you would actually do that logic again, which is actually very annoying. But this is the only time you use n, I think. And then we can do it here like this, right? Let's run it real quick. What? I'm confused. What am I looking at? Key error ABC, but why is there why is there an ABC? Oh, target path doesn't have to be in one of the nodes. That's such a weird thing to do. I didn't expect that, huh? I didn't even see it here. Oh, okay, now I see it, but okay. I mean, that's fine. We just had if name in lookup, just like -1, right? It doesn't really matter. And then now we can kind of see with the edit distance, right? So this one we have an edit distance of 1. We have 8 for the second one and 0 the third one. So let's see if distance matches. 8 and 0. So we have the right answer. Of course, we have to do two things. One is memorization, and second one is path reconstruction, right? Because we have to return the path. So first of all, let's do the memorization. I'm just going to do it the same way that I always do it, right? What is it? P. Right? No, this is the inner. Inner would be N. Okay. So I'm just writing the memorization. The idea, of course, is that for every same input, you get the same output. Very basic dynamic programming stuff. In a way, today I'm not going. Usually I try to explain this part a little bit more, but today I am very tired, and also this is a very hard problem, relatively. Maybe not very hard, but decently hard. So, yeah. So I'm going to assume that you have the prerequisites for this video. Sorry, friends, if I'm a little bit lazy. Okay, what am I doing? Oh yeah, I just cached this. But now we have to do a path reconstruction. And that part is not so bad. It's just annoying because now we have to basically go for, let's just go with like choice or something, right? And it just basically allows you to make the best move for each one. It's a little bit more annoying because this thing doesn't have a state, but that's okay. Let's see. Right, so now score is equal to this thing, right? If score is less than best, then best is equal to score. So this is how we take out the min, and then the way that we can do it is just, you know, choice sub index and current is equal to v, and that's really it. To be honest, I mean, that's the thing that so that every state you keep track of the choice you made or you want to make, right? Is this enough? Yeah, okay. Because sometimes the best answer may be outside this for loop, which in this case it can be if it's infinity, but then I don't think that makes sense. But Yeah, in this case, choice will be none anyway. So then we have to do the same thing here, right? Right, and then now we go, okay, so first is equal to I maybe, right? I am so tired. I not gonna lie, I have crazy allergies, and like I'm having some trouble breathing a little bit right now. So I need to like wash my face and stuff. So excuse me, but yeah, everything's very itchy. Okay, yeah. So then now we just assume that the first one is cache. So then now we constructed path is equal to this, right? And then current is equal to first, and then while current is not none. What is this? Is this the right way to say it? No. Or maybe current is, but current node maybe, and then the current step maybe is equal to 0, and then now while current node is not none, right? We constructed path dot append what is it, names? Yeah, okay. Name sub current node, and then now current node is equal to choice of current step and current node. And of course current step we increment by 1, because we always go one step forward in the way that we construct it. In some scenario for path reconstruction, you may actually have to store, you know, whether you get +1 here, but in here it doesn't seem necessary, so it's fine. Yeah. Oh, we don't have to, this is so weird. So we're not returning the name, we're returning the node. So okay, so we don't need the names. Let's take a look. Looks good for this one and the first 3. So let's give it a YOLO submit. Maybe I made, you know, some mistakes, but should be okay. Hopefully not time limit exceeded. Oh, wrong answer. Why? Tell me why. Oh. That's weird. I mean, the tricky thing is that, I don't know, there's a lot of... Do we have to go somewhere? I think maybe that's the thing that I'm not sure about. Like, you can't stay still, right? They don't stay still, at least in their answer. So why is that wrong? Do I have a weird typo? Don't know why this is wrong, actually. I mean, it's not the same answer, but there could be multiple answers. This is so silly, though. The way that they like can, or like it just feels inconsistent that they give you the input like this, and then they make the output in nodes or in index. So then it's just a little bit awkward, but not a big deal. But it just makes it harder to read, you know. Let's see. So the answer here is 15. This is just like a mess to read. I don't even know if this is like, I don't know. I don't know what the score here is, right? So probably just have a typo somewhere, but they're the same length, so we didn't do anything funky with respect to that. That part is good. And we don't return none or anything, so I feel like this should be good. Unless I'm misunderstanding like the beginning or something like this, but it doesn't have to be the same in the beginning, right? So we could start on any city, and You can reach any city. Why? No, that's not the same. Yeah, no, this is the entire thing. So yeah. Huh. I mean, it may be that I have some very silliness. Within the last path, do you do this? That's the only thing that I could imagine us doing something weird. But maybe I could do a assert. Nope, so that part is good. Huh. To be honest, I have no idea. Because it's any answer can do. Let's see, right? For x and p, if name sub x is not equal to target path, or whatever they call it, target path sub x, or sub I guess, whatever. One, really? I don't think that's quite it. Yeah, there's no way 0 and 1 doesn't make sense, but okay. Wait, what? Oh, I did not look at this carefully. I hate you. Okay, I get it. Okay, that's a pretty. Okay, I see. And I just didn't look at this input closely. But the reason why is because the names are the same. I didn't know that could be a case. Maybe that's why there's so many downloads. I was just doing them by the indexes. I mean, it's not hard. It's just, oh my god. Okay. I hate you. I mean, it's just about removing this then, right? And then this is good enough. Target path. Where is the path? Why does that work? Huh. And all right, now this works again. Do I have any print statements? No. All right, let's give it some. See if that. What an annoying thing that they make you do. All right. I mean, yeah. I mean, there's some optimization you can do so that you don't have to make a 3-character string comparison very often. But I'm also okay with that. It's fine. Sorry, I had to refresh a little bit. Yeah. What's the complexity here, right? Well, index go from 0 to n. Current could go from 0 to... Oh no, index could go from 0 to p. Well, that's the length of the path. Of course, this is only 100, I believe. If not, then I don't know. Yeah, path is only 100. Current is the node, so it's 0 to n, also 100. And each input takes O of n times, because that could be n items in adjacency list. So this is also 100. Overall, so this is n squared times p, or 100 cubed, or a million. 1 million. So that's going to be fast enough, as you saw. And then the reconstruction, this is just a while loop, this is linear, right? So yeah. That's all I have for this problem. Let me know what you think. I don't think this one is that tricky. It's just, well, I mean, there are a couple of really silly things, but other than that, it's fine. So the 1 was correct, the score of 1, but it's just that I missed it. But yeah, let me know what you think. Here you can see the top. Here you can see the dynamic programming memorization function, and then the path reconstruction. So yeah, that's all I have for today. I need to get some sleep. Hopefully I get some, so wish me luck. Anyway, stay good, stay healthy, to good mental health, and stay cool. I'll see y'all later and take care. Bye-bye.